You are welcome to DaveTuts Academy, where we are devoted to building academic excellence in students in the STEM subjects. Now, we are going to be looking at the detailed solution to the Post UTME Exam 2018 in Mathematics for OAU. But if you are not even choosing OAU as your school of choice, this is going to help you because at least we have the standard from OAU that you can also use to prepare. Now, you checked your results, you are glad you scale above 200, but then there's this order of the Post UTME to scale through. Your preparation is not yet through. You still need to grind in, do the hard work, and that's what we are here to help you do. So what we're going to be doing is we're going to be looking at all the questions, the 10 questions that OAU set for 2008 in their Post UTME Mathematics examination, and I'm sincerely wishing you all the best. I want you to gain that admission, so let's go ahead and learn together. So we have this logarithmic equation. We are given that log to base y of 4 plus log to base 4 of 1 over y is equal to 2 over 3 all raised to power minus 1. We need to note some things that will help us to solve this question if we are to solve for the value of y. And first and foremost, we need to know that when we have 1 over y, that is the same as y raised to power minus 1. That is our basic law of indices. Then when we also have 2 over 3 raised to power minus 1, that means it is 1 divided by 2 over 3. And if you are to express that, that will be 1 multiplied by 3 over 2, which is equal to 3 over 2. So our right-hand side is going to be 3 over 2. Then if we have log to base y of 4, that is going to be the same as 1 over log to base 4 of y. Inverting the base and the logarithm, we are going to have the inverse of the logarithm of what we have initially. So using all this, let's see what we can do with this question from OAU 2018 Post UTME Mathematics. If we are to take our equation log to base y of 4 plus log to base 4 of 1 over y. Now 1 over y we know will now be y raised to power minus 1. And that will be, we have gotten our 2 over 3 inverse to be 3 over 2. So what else can we do with this? Another rule of logarithm is telling us that when we have a power, a logarithm raised to power a power, we can bring the power down to the front of the logarithm. So these are a particular expression we can write as log to base y of 4 minus, because minus 1 is a power, minus log to base 4 of y is equal to 3 over 2. So now we have log to base y of 4 minus log to base 4 of y. These are the inverse of one another. So we can say log to base y of 4 minus 1 over log to base y of 4 is equal to 3 over 2. So now we only have an unknown log to base y of 4. So if you say that let x be log to base y of 4, then our equation becomes x minus 1 over x is equal to 3 over 2. And we find the LCM of the left-hand side. This is x. The first one is over 1 multiplied by x. That will be x squared minus 1 is equal to 3 over 2. And if we cross multiply, 2 is going to multiply the whole of the numerator on the left-hand side to give us 2x squared minus 2 is equal to 3 times x is 3x. So if we just take everything to the left-hand side, we are going to have 2x squared. When 3x cross to the other side, it will become minus 3x. Then we have minus 2 is equal to 0. This is the quadratic equation that we can try to solve by whatever method we have. Let's look at the factors that will be relevant to us. We have the product to be 2x squared and minus 2, which will be minus 4x squared. Then we have the sum. This is the product. That's going to be the product of our factors. Then the sum of the factors is going to be minus 3x. So if we take minus 4x raised to power 2 and we are to consider the factors that will make up that, we can have minus 4x and x. And if we add minus 4x and x, that will also going to give us minus 3x. So this will be suitable for us to use as the factors for this particular quadratic equation that we have. So instead of having minus 3x as the second entity, we are going to have minus 4x plus x. So we have, this will give us 2 x raised to power 2 minus 4x plus x minus 2 is equal to 0. It's as if we are just writing minus 3x as minus 4x plus x. So if you look at the first two terms, 2x squared and minus 4x, 2x is common to give us x minus 2 in bracket plus 1 into x minus 2 is equal to 0. So this will yield 2x plus 1 into bracket x minus 2 is equal to 0. These are the factors of the quadratic equation such that 2x plus 1 is 0 or we are going to have x minus 2 is equal to 0. So from the first entity, 1 will move to the other side and becomes minus 1 such that x will be minus 1 over 2, or x will be, when 2 move to the other side, it will be 2. But nobody gave us x. We are the one that introduced x. Originally, x is equal to log into base y of 4. And the last rule of logarithm we are going to be employing is that when we have an entity like this, and we have if we have x is equal to log into base y of 4, that means y raised to power x is equal to 4. So in this particular case, if we are going to apply this rule, we are going to say log to base y of 4 is equal to, in the first case, x is minus 1 over 2, and then in the second case, log into base y of 4 is equal to 2. These are the two things we need to solve for. So here we are having that y raised to power minus 1 over 2 is going to be 4 based on the last rule that we highlighted. And then looking at this, if you multiply the power of the left hand side and the right hand side by minus 2, you know what we are doing to the left, we are doing to the right. So it's as if we are really not affecting our equation. We want to do this to cancel out minus 1 over 2. So we are going to have the expression become something like y raised to power minus 1 over 2 multiplied by minus 2 is equal to 4 raised to power minus 2. We are doing the same thing to the left and the right hand side. So now the negative will cancel and the 2 will cancel, so that y will be 4 raised to power minus 2. And from the law we raised before, that will be 1 over 4 raised to power 2, which is 1 over 16. And then in the other case, we can also say this will give us y raised to power 2 is equal to 4. And we know that 4 is also 2 raised to power 2. So we can say y raised to power 2 is equal to 2 raised to power 2. Since the powers are equal, then the base are also going to be equal. So that our correct option here is option number D. Y is 1 over 16 or y is 2. These are the correct values of y. In this question, we are told that a sector of a circle of radius 50 centimeters, subtending an angle of 200 degrees at the center of the circle, is bent to form a cone, and we have to find the base radius of the cone so formed. So here we have our circle, and we want to look at the sector of the circle, which is subtending an angle of 200. Now, the sum of angles at the point is 360. So 200 will take the larger share because it's greater than half. So that means our major sector here is going to define angle 200 degrees. And then we are told that the radius is 15 centimeters. And this, the major sector of the circle was used to form a cone. So meaning that this upper region, let me see if I can shade that. The region that's being shaded in blue was the region that was cut out to actually make a cone. Now, there's going to be a transformation whenever we're transforming the sector of a circle into a cone. And we are going to see that relationship. So in this particular case, we are going to form a cone. It's going to have its own base circle. In the sector of the circle, we have the radius r as 15 centimeters. That r will transform to the side of the cone, but we have to find the radius of the base of the cone, the base radius of the cone that was formed. Now, we need to note something. If this is the major sector, the length of this arc that's being shown in red, that length of the arc of the major sector of the circle is going to be the circumference of the base circle that is formed by the cone. So it's going to traverse through to the length of the whole. That length of the arc is going to be the circumference of the base circle of the cone. So the length of the arc is given as theta over 360 multiplied by 2 pi r. Now our r for this circle is the big R, and then the circumference of the cone, the circumference of the base circle of the cone, circumference of the base circle is given as 2 pi r, but now it's going to be the radius of the base of this cone. Now, because the length of the major sector of the circle is what is being transformed to the base of the cone, we can equate the two so that we have 200 over 360 multiplied by 2 pi. Our r is 15, is going to be equal to 2 pi multiplied by the radius, the base radius of the cone that we are looking for. We can divide and cut out. 2 pi will cancel themselves out so that the radius is going to be, here we have 15 times 200 divided by 360. So we can cut out our zeros. 3 can go in 15, 5, 3 can go in 36, 12. So this will be 5 times 20 is 100 over 12. And if we want to, 100 over 12, if we have 12 times 8, that will be 96. So we have 12 in 100 will give us 8. 100 minus 96 will be 4 over 12. And of course, 4 over 12 is also 1 over 3 because 4 can divide them. So 8 whole number 1 over 3 centimeters. That will give us option B, 8.33 centimeters. Here in this question, we are told to find the solution set of the probability 3y plus 2 is greater than or equal to 2y plus 1, which is also greater than 3y minus 4. What we need to do is, first and foremost, we need to actually separate this inequality into two. So we are going to take the first one to be 3y plus 2 is greater than or equal to 2y plus 1. So if you are to collect like terms and put y on the left, that will be 3y minus 2y is greater than or equal to, now we have 1 minus 2. Okay, so 3y minus 2y is y, which is greater than or equal to minus 1. This is quite easy. We have that. So the other one, we are going to have, let me take my red ink. 2y plus 1 is greater than 3y minus 4. Now, in the same way, we're also going to collect like terms, put y on the left-hand side, and then the other constant on the right-hand side. So in that case, we are going to have 2y minus 3y is greater than minus 4. When 1 moves to the other side, it will be minus 1. So this will be minus y is greater than minus 5. But then, if we want to eliminate the negative sign, we can say we want to multiply by minus 1 or we want to divide by minus 1. But because this is inequality, it's going to affect our inequality sign because the sign always changes whenever we are multiplying or dividing by a negative number. This is where students will tend to mix up this question. Note that the sign will change when you multiply or divide by a negative number. So in this particular equation, if you are to say that you can choose anyone just to eliminate the negative sign. So let's multiply through by minus 1. We are going to be using minus 1 to multiply. So now the left hand side will become y, but it will change our sign. So it will be y is less than 5. So these are the two solutions to the inequality. And if we are to represent this on the number line, we have minus 1 and we have 5 that we want to note on our number line. Then we also need to note in the first case it is y is greater than or equal to minus 1, and in the second case it is just y is less than 5. So because it is greater than or equal to, that's going to be a solid circle because or equal to is involved. So you have a solid circle. Then in the other case, it is just that y is less than 5. That is just going to be an empty circle. So the solution is Of course, y is greater is going to the right, y is going to the left. So the two will have this common solution. And if we are to write out the solution, we are going to have minus 1 is included because we have or equal to. So we have minus 1, 0, 1, 2, 3, and 4. 5 is not going to be included because it is less than 5. So our solution is option A. In this question, we are to determine the minimum value of the function y is equal to 2x raised to the power 3 minus 3x raised to the power 2 minus 36x plus 8. Now, the question before us is, how do we get the minimum value? Now, as a rule of thumb, a function of x has minimum value at x is equal to, let's say, solution A if two conditions are met is equal. And the first is that the derivative of the function when we input the value of a is equal to 0, and the second derivative is positive, that is, it is greater than 0. And well, we can also define the case for the maximum value. So function of x, the function will have a maximum value at the point, let's say x is equal to b if two conditions are met. So if first the derivative of the function when we input the value b, the derivative is 0, and the second derivative of the function when we are using the value of b is less than 0, that it is negative. Now, not to be confused, what we need to note is that for the minimum value, the second derivative is positive, while for the maximum value, the second derivative is negative. We just need to know this. For the minimum value, so the second derivative is positive. For the maximum value, the second derivative is negative. And we will use the solution when we have the derivative of the function and equate it to 0. So in our particular question here, we have the function of x, which is y, is 2x raised to the power 3 minus 3x raised to the power 2 minus 36x plus 8. So we need to find the derivative of this function. We need to find the differentiation of y with respect to x. And generally, for y is equal to a multiplied by x raised to the power n, where a is a coefficient, the derivative is going to be, we are still going to have the coefficient, then we'll bring the power down, then subtract 1 from the power. And this, we are going to apply in this particular function, y is equal to 2x cubed minus 3x squared minus 36x plus 8. So our first derivative is going to be 2 multiplied by the power, which is 3. Then we subtract 1 from the power. So we have x raised to the power 2. Minus 3 multiplied by the power, which is 2, multiplied by x raised to the power 2 minus 1, which is 1. We don't need to write that. Then minus 36. Now this is just like saying that x raised to the power 1 minus 1, which will be 0. And of course, any number raised to the power 0 is 1. Then for the 8 is as if we have x raised to the power 0, which is 1, so that will actually cancel out itself. So if we are to expand our bracket, we are going to have 6x squared minus 6x minus 36, because 1 minus 1 is 0, and any number raised to the power 0 is 1. So we have minus 36. So this is the first derivative. Now, we need to actually get the values of x for this particular derivative. So if we equate it to 0, and we can see that 6 is common, we divide all through by 6. We're going to have x squared minus x minus 6 is equal to 0. We want to factor out this quadratic equation now. And we're having, if you look at this, we can say that our factors of minus 6x squared, which is the product of the factors, and then the sum of the factors, we will need to sum them to be minus x. So if we have to look at the factors of minus 6x squared, okay, 2 factors is what we need, and each of the factors will carry x. So let's look at the number now. We can have minus 6 multiplied by 1, okay, we know that each will take x. Then we can also have minus 3 multiplied by 2, or we can also have minus 2 multiplied by 3. But which of these are we going to actually sum to give us minus x? That will be minus 3x and 2x. So in the middle of our quadratic equation, instead of writing minus x, we are going to replace with minus 3x plus 2x. And we know minus 3x plus 2x is originally minus x. So it's as if we are just expanding our equation. Now for the first two entries now, x is common. So we have x into x minus 3. And in the second set, 2 is common. So we have 2 into x minus 3. That means our factors are going to be x plus 2 and x minus 3. These are the two factors of the quadratic equation, meaning that x is equal to minus 2 or x is equal to 3. Now, we need to know which of these two solutions is going to give us a minimum value and which of them is going to give us a maximum value. Remember, we are asked to get the minimum value of a function. So, for us to get that, we still need to proceed forward to get the second derivative of our function, the function that was given as y in the original equation. So we are coming from the notion that x is minus 2 or x is 3. One of them will give a minimum value, the other is going to give a maximum value. We don't know which one yet, so we need to test by using the second derivative of our function. So now, to get the second derivative of our function, we need to recall that the first derivative we got to be 6x minus 6x squared minus 6x minus 36. So now for us to get the second derivative, we differentiate this first derivative with respect to x. So we have d square y dx square, and that will be, we've noted the rule before, this will now be 12x minus 6. So when x is equal to minus 2, let's plug the value here. Then the second derivative of the function, putting 2 into the equation, will be 12 multiplied by minus 2, maximum minus 6. That will be minus 24 minus 6, which is minus 30. This is a negative number. This is less than 0. So this is actually the maximum. This is going to be the value for the maximum value, not for the minimum value, because our rule of thumb is saying that if the second derivative is less than 0, then that particular point is going to give us a maximum point, not a minimum point. Our question asks us to find the minimum point. So let's check the other solution. For x is equal to 3, the second derivative of our function will be 12 multiplied by 3 minus 6. And that will be 12 times 3 is 36 minus 6. That is equal to 30, which is greater than 0. So good. This is our minimum point because the second derivative using this value that we are considering is going to give us a positive number. So this is our minimum point. So we've gotten x equal to 3 to be our minimum point. For us to get the minimum value, we substitute this value of x equal to 3 into our original equation. So we can say that we can get the minimum value to be the function of 3. So that will be just anywhere we see x, we put 3 in the original function. So we have, in this original function, we are going to put 3 in place of x. So we are going to have 2 multiplied by 3 raised to power 3 minus 3 multiplied by 3 raised to power 2 minus 36 multiplied by 3 plus 8. So 3 raised to power 3 is 27 times 2 minus 3 raised to power 2 is 9, then minus 36 multiplied by 3 plus 8. So 27 times 2 is 54, 3 times 9 is 27, 36 and 3, that will be 18, plus 108 plus 8. So we need to actually do this operation. 54 minus 27, that's 27. Then 108 minus 108 plus 8 is minus 100. So we have this to be minus 73. That means the minimum value of the function y is equal to 2x raised to power 3 minus 3x squared minus 36x plus 8 is minus 73. And that is our option number B. Yes, that's it. In this question, we are to find the values of x and y respectively if we are given these two matrices multiplying one another to give us a third matrix. So, first and foremost, let's write out our matrix 3, minus 4, 5, and 7 multiplying the column matrix xy, giving us a column matrix 10 and 3. Now, having this, how do we open up this multiplication of matrices? Normally, when we do multiplication operation on matrices, we multiply the row by the column. So the first row, 3 and minus 4, is going to be multiplying the column x and y to give us the first entity in the right hand side, 10. So let's try and open up that bracket and multiplying it out. So we are going to have 3 multiplied by x is 3x plus minus 4 multiplied by y is minus 4y is equal to 10. Now, exactly the same operation that we carry out to expand this bracket, we're also going to do on the second row, multiplying the same x and y to give us the second entry in the column matrix, which is 3. So we have 5 and 7. Let me know that 5 and 7 is going to multiply x and y to give us 3. So if you are to carry out this operation also, 5 multiplied by x will give us 5x multiplied by plus 7 multiplied by y is 7y is equal to 3. So we have our set of simultaneous equations in 2 variables, and we can use whatever method we find useful for us to solve for this simultaneous equation. So we can call the first one, we can say the first one is equation 1 and the second one is equation 2. Now, for me, I want to employ the elimination method. I'm seeing that I have minus 4y and plus 7y. If I multiply the first equation by the coefficient of y in the second equation, which is 7, so equation 1 is 7, I will get the whole of those values multiplying each entity, so that y, I'm going to knock it out. Equation 2, I can use the coefficient of y in the first equation to multiply equation 2, that is 4. I'm doing this because you can see I have minus 4y and plus 7y. If the coefficient of y is the same, I can add the two equations and knock out y, then I will be able to solve for x. So equation 1 times 7, that will be 7 times 3x is 21x. 7 times minus 4y is minus 28y. 7 times 10 is 70. So I have that as one of my equations. The other one, equation 2 multiplied by 4. 4 times 5x is 20x. 4 times 7y is 28y. 4 times 3 is 12. So these two new equations, I'm going to be adding, and I can call them equation 1 and equation 3 and equation 4. 1 had been used up, so let's say this is equation 3 and this is equation 4. So I want to add equation 3 and 4 so that minus 28y and 28y will knock out each other, so that I have only a variable in x and I can solve for my x easily. So equation 3 plus equation 4, that will give 21x plus 20x, that will be 40x. So I'm adding the 2, that will be 41x, mind you, 41x. Then minus 28 and plus 28y will cancel out. 70 plus 12 will be 82. So I can divide both sides by 41 here. Divide both sides by 41 so that x will be 2. So now I've gotten the value of x to be 2. This value of x I can plug into any of the 4 equations and I'm still going to get the same answer. So I think I will opt for equation 2 using the value of x is equal to 2 in equation 2. So where I see x, I will now use the value of 2. So I'm going to have 5 multiplied by 2 and not 5x again. So 5 into bracket 2 plus 7y is equal to 3. Now 5 multiplied by 2 is 10. I have 10 plus 7y is 3. When 10 moves to the right hand side, it will change sign to be minus 10. So I have 7y is equal to 3 minus 10. And 3 minus 10 is minus 7. So if I divide both sides by 7, the value of y I will get to be minus 1. So now, we are asked to find the values of x and y respectively, meaning that it must follow that order. And our x is 2 and y is minus 1. So the correct option is option A. And we are asked to find the sum of all the multiples of 5 between 1 and 200. Okay? The multiples of 5 between 1 and 200. If we are to look at the multiples of 5, we are going to have 5, 10, 15, 20, 25, 30, 35, and on and on and on like that. 5 times 1, 5, 5 times 2, 10, 5 times 3, 15. So now, if we are very observant, this is actually resulting to an arithmetic progression in which we have our first term and we have common difference. So since we are saying multiples of 5, the first term A, as you can see, is actually 5. So the first term A is 5. Then the common difference, the difference in subsequent entries that are common to all the repeated values, we are going to see is represented as D. 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15 is 5. So the common difference is also 5. So we have our first term as 5. We have our common difference as 5. Then we need to note something. They said it is between 1 and 200. What does that mean? When they say it is between, that means 200 is not inclusive. It is only between. 1 is not inclusive, 200 is not inclusive. Now 200 is our focus area, because if we add 200, it's going to give us a totally different set of answers. But now that we know that 200 is not included, we can try and see how do we get the sum of the terms between 1 and 200. Now, generally for an AP, an arithmetic progression, the sum of the first n terms is given as n over 2 into 2a plus n minus 1 as written. But now we have A and we have D, but we don't know n. We don't know the number of terms. So how do we go about finding the number of terms? Now, looking at this arithmetic progression, what is the last term for this particular case scenario that we are given between 1 and 200? The last term is given as, the nth term is given as Tn. So for this particular case, between 1 and 200, the last term is going to be 195. Because 195 is going to be the last multiple of 5 before 200. So generally, the nth term is given as A plus n minus 1 multiplied by D. And we have A, we have D. So we can substitute this value and use 195 as our nth term so that we can find the number of terms between 1 and 100. So 195 is going to be equal to 5 plus n minus 1. We are looking for n. We know our D is 5. So if you are to open that bracket, it will be 195. 5 is equal to 5 plus 5 multiplied by n is 5n. Minus 1 multiplied by 5 is minus 5. The 5 will cancel out each other so that 5n is 195. And if we divide all through by 5, our n we are going to get as 5 in 19, that is 3 in 45, that is 9. So n is going to be 39. Good. So now our number of terms we have gotten, we also know our first term A, and then we also know the common difference D. Let's use all these values and get the sum of the terms between 1 and 200 when we are talking about multiples of 5. So this sum is going to be 39, which is n over 2, into bracket 2a. Our A is 5 multiplied by n minus 1. N is 39. So 39 minus 1 multiplied by D, which is 5. So we can say this 39 over 2 into 2 multiplied by 5 is 10, plus 39 minus 1 is 38. 38 multiplied by 5. Now 38 multiplied by 5, 38 over 2 is 19. 19 times 10 is 190. So we have 10 plus 190. 38 times 5 is 190. So we have this as 10 plus 190. So that will be 39 over 2 multiplied by 200. So 2 can go here, 1, 2 in 200, 200. In 200 is 100. So the sum of the terms will be 3,900, and that is option number C. What we need to note is that we are at these values between 1 and 200 is not going to be included in that particular scenario. We are told that a school employs 79 staff, 52 of whom are men, 38 staffs, including all the women, are clerical staffs, and we are to find the number of men that are clerical staffs. Now, a good word problem for us to just juggle with numbers and find this. The total employee is 79. So you've been told that the total employee is 79. So the total number of employees, including the men and the women, all of them, they are 79 in number. So total employees, including the men and women, is 79. Now, out of this set of people, we've been told that 52 of them are men. So, men among the employees, there are 52 in number. So, the number of women we can get as 79 minus 52, and that will be 27. So, the number of women that were employed is 27. Now, we are giving additional information, and we are told that 38 staff, including all the women, are clerical staff. So, the number of clerical staffs, which comprises of all the women that were employed in this particular company, all of them are employed as clerical staff. So, the clerical staff comprises all women is 38. Now, if we take out all the women from the clerical staff, all the women is 27, but all the clerical staff, which comprises of women and men, is 38. So, the clerical staff that was given as 38 comprises of all the women, which is 27 women, plus the number of men who are clerical staff that were asked to find. We can call that X-Men. Wow, X-Men? No. I'm not talking about the mutant X-Men, Professor Xavier, Cyclops, Jean. No. We are talking about the number of men who are clerical staffs here. So that means that our X will be given as 38 minus 27. And 38 minus 27 is 11. So we have 11 men as being employed as clerical staffs. That's option D. In this question, we're asked to convert 125 in base 6 to a number in base 2. So how do we transition from base 6 to base 2? Our best means of solving this question is to first go ahead and convert to base 10, and then from base 10 we can go to base 2. As a rule of thumb, if we are giving a number in any base to convert to another base, let's first convert to base 10, then we can go from base 10 to any other base as requested. So how do we now get this 125 base 6 to base 10? We are going to multiply each of the digits by 6 raised to power the corresponding power of 6. So now for like the last entry 5, we have 6 raised to power 0, for 2 6 raised to power 1, and for 1 6 raised to power 2 as shown. So 1 times 6 raised to power 2 is 36, 2 times 6 raised to power 1 is 12, 5 times 6 raised to power 0, any number raised to power 0 is 1. So that will be 5 times 1, which is 5. 36 plus 12 plus 5 will be 48 plus 5. That will be 53. That will be 53 base 10. So 125 base 6 is actually 53 in base 10. So now we have 53 in base 10 that we want to convert to base 2. We are going to achieve this by doing a division by 2 and noting all the remaining value when we are dividing 53 by 2. And then all those remainders are going to constitute what will yield the number in base 2 for us. So to convert 53 base 10 to base 2, we divide by 2 and take all the remaining values, the remainder values. If it is 0, then we note 0. If it is 1, we know 1. And those are the only two numbers that we can have as our remainder, either 0 or 1. So now let's draw up our long division. We have 53. I want to be dividing by 2. So we have 2 in 53. 2 in 5 is 2, remaining 1. 2 in 13 is 6, remaining 1. So we have plus 1. 2 in 26. 2 in 26 is 13, and there is no remainder. So we have plus 0. 2 in 13 is 6. 2 times 6 is 12. So we have 1 as our remainder. 2 in 6 is 3, and there is no remainder. So we write plus 0. 2 in 3 is 1, and there is going to be a remainder 1, because 2 times 1 is 2, and 3 minus 2 is 1. 2 in 1 is 0, and we have 1 as our remainder. So our value of 53 in base 10 converted to base 2 will be this value taken from the base up. So we have 1, 0, 1, 0, and 1 in base 2. And this is option C, which is the correct answer for us to pick. So in this question, we have to calculate the amount if simple interest is paid yearly at 10% per annum for 2 years on a principal of 12,000 naira. So our question first and foremost is, how do we get the simple interest? Well, it's quite simple. The simple interest is quite simple anyway. The simple interest is giving us the principal multiplied by the rate multiplied by the time, all divided by 100. So here we are going to have principal times rate times time all over 100. And the value for the principal, the rate, and the time had been given for us in the question already. So if we are to substitute that, we are going to have our principal is 12,000 naira. So we have 12,000 multiplied by our rate. The rate is 10% per annum. So multiplied by 10, and then the year, the time is 2 years. So we have multiplied by 2, all divided by 100. So the 100 zeros will cancel out for us to have 120 times 10, which is 1,200, multiplied by 2, that is 2,400. So the simple interest is 2,400 naira. But we are not asked to calculate the simple interest. We are asked to calculate the amounts if the simple interest is paid yearly. So the amount will be the sum of the principal and the simple interest. So in this particular case, what we are going to have is the principal, which is 12,000. So we have 12,000 naira plus the simple interest, which is 2,400. So if you add that, that will give us 14,400 naira, and that is going to be the amount. So the correct option from this question is option number B, 14,400. So in this question, we are told that 5 years ago, a mother was twice as old as her son. In 6 years' time, the sum of their ages will be 82. We have to find their present ages. Now, interpreting this question correctly will help us to solve it. We are given a calendar timeline looking at 5 years ago and 6 years into the future, and we have to find the present age. So let's draw our calendar line, in which presently we are going to be using today as a reference point, and that is 0. 5 years ago will be minus 5. We are going to the past. That's 5 years ago. And in 6 years' time will be 6 years into the future. That will be 6. So we have this, and presently, if we represent the age of the son as X, the son's age, let's say it is X, and then the mom's age, let's say it is Y. Today, the son is X years old and the mom is Y years old. So we can look at representing our information on our calendar line. Presently, the son is X, the mom is Y. 5 years ago, the son is going to be X minus 5 years old, while the mom will be Y minus 5 years old. In 6 years' time, the son will be X plus 6 years old, and the mom will be Y plus 6 years old. Now, this is going to help us a lot in interpreting our question. So for the first case, we are told that 5 years ago, the mother was twice as old as her son. So what we are going to be using is X minus 5 and Y minus 5, because that is their ages 5 years ago. So we can now say the mom is Y minus 5. It is equal to twice the son of the age, which is X minus 5. And if I were to open this bracket, that is happening 5 years ago. So if we are to open this bracket, that will be Y minus 5 is equal to 2X minus 10. So further working on this, we can have minus 5 plus 10 is 2X minus Y. That will be 2X minus Y is equal to 5. That is equation 1. That is the relationship between their ages 5 years ago. 2x minus y is equal to 5 is the relationship between their ages 5 years ago. So in 6 years' time, what is going to be the relationship between the age of the mom and the son? We are told that in 6 years' time, the sum of their ages will be 82. So you can say that what is the age of the son in 6 years' time? That is x plus 6, right? Then we also want to look at what is the age of the mom in 6 years' time. That is y plus 6. The sum of these two is going to be 82. So if you open up our bracket and just add them together, we can say x plus y plus 6 and 6 is 12 is equal to 82. If you take 12 to the right hand side, that will be 82 minus 12, such that x plus y is equal to 70. We can call this equation 2, and we have these two sets of simultaneous equations that we can solve, because solving them will give us the age of the son, which is x, and the age of the mom, which is y. Now I want to use the elimination method because I'm seeing minus y and plus y. So if I add the two equations, that will knock themselves out, and I can solve for x and subsequently substitute to get y. So adding equations 1 and 2, I'm going to have 2x minus y for the first case plus x plus y for the second case is equal to 5 plus 70. So if I'm to open that bracket, 70 minus y and plus y will cancel out. 2x plus x is 3x, and that is 75, such that x will be 75 divided by 3, and that is 25. So the son is 25 years old presently. So if I'm to use the value of 25 as the age of the son in equation 2, y will be 70 minus x, and that will be 70 minus 25. 70 minus 25 is 45. So presently the mom is also 45 years old, while the son is 25 years old. So their present ages x and y will be 25 and 45. Option B is the correct answer. So with that, we have handled the detailed solution to all the 10 questions that were set in the OAU Post UTME Mathematics Exam for the year 2018. Now, our advocacy is that, see, the more you practice with these things, the better your chances are at aiming for success. Doing all this, I prepared you for the likely questions that might come out from your exams. And as you are preparing for your admission, we're actually wishing you the very best of luck. We are praying along with you. We want you to actually go out there and build academic excellence that you can build your career on subsequently. It's DaveTuts Academy, and if you really enjoyed this video, if you have found it useful, please go ahead and click on the subscribe icon, click on the notification icon, and share with your friends, share with your loved ones. Leave your comment below. Let's get feedback. Let's know what we are doing best. Let's know what we need to improve upon. Let's know what we need to drop, and let's know the ones that we also need to pick up. And with that, we can all build academic excellence together. Until next time, go ahead and be the best. God bless you.